Hello sir, my name is Rishabh, 19MIS0245, and here I am to brief you about leakage incident in cross-country crude oil pipeline. Let's first understand the problem statement. The leakage happened due to a burst in the pipeline which was operating at 59 kilograms centimeter square with a flow rate of 2450 kiloliter per hour. This pressure flow caused a tripping of the main line pump due to a low suction. The fitness of purpose assessment report indicated that there were 1,000 anomalies having ERF greater than 1 using a ASME B31G criteria. The pipeline was repaired by sleeving in very close to the burst points. There were a few burst points in the pipeline which were repaired by a process called sleeving. The gouge mark due to mechanical damage was not reported by the contractor during the pipeline repair work, and coincidentally the pipeline was burst at this very exact point where the scratch were very deep and very intense due to the pressure of the pressure inside the pipe. This scratch led to an opening in the pipeline and the hazard happened. Work permit was issued to the contractor for sleeving job. However, neither the permit was signed by the contractor nor the permit was closed after the completion of the work. At the time of the leak incident, the leak detection system LDS was not functional, so the system was unable to identify any kind of leak. Contractor also did not report any incident though the damage was visible on the pipeline. So here we can see that the pipeline had few scratches where the sleeving wasn't done properly, and though the scratch was visible, the contractor did not report it, and neither the permit was closed. What is the purpose of this study? The major purpose of this study is to identify what went wrong and what led to this accident. Already in the above mentioned points, we have discussed the issues which were present in the pipeline, the negligence of the authorities during the inspection, and the negligence of the contractor that he did not report that the scratches, the gouges or the scratches present on the pipeline. But this case study also has a few recommendations that would help to prevent the hazard from occurring. The operators have been advised to constitute a committee to identify the scope of improvement in the contract clauses related to pipeline safety, and also to ensure the methodology to witness and assess the pipeline repair work by the operator personnel. The defect repair carried out in supervision of the contractor, it is recommended to have a ILI run with the crack detection capability tool on priority, and also to assess if any such cases at other location where the sleeving work was done. The reliability of the SCDA and the leak detection system must be ensured, and the status should be reviewed during the top management review meeting. How can we implement Aloha software and what help can it be in such leak detection system? Aloha is the hazard modeling software program for the CAMEO software suite which is used widely to plan for and respond to chemical hazardous material emergencies. Aloha software allows you to enter details about a real or potential chemical release, and then it will generate threat zone estimates for various types of hazards. The Aloha model can model toxic gas clouds, flammable gas clouds, PLEVs, jet fires, pool fires, and vapor cloud explosions. The threat zone estimates are shown on a grid in Aloha, and they can be plotted on maps in MARPLOT. The red threat zone represents the worst hazard level, and the orange and the yellow threat zones represent the areas of decreasing hazard. we also have a text summary window which displays the scenario information the user has entered, the physical properties of the selected chemical, and also the aloha strength, threat zone, and the threat at a point estimated as text. Thank you, sir.